Okay, so in this next part, we're going to use the roster method. Now, when I get ready for this class, before the first day, I printed out a roster. The roster has every name of every person in the class, and it's a countable list. It's finite or infinite. Is my roster infinite or finite? If I can count it up, it's finite because it's not an unlimited list of, So when we use the roster method, we're literally making a list of all the elements of the set. What would be the set of all months of the year whose names begin with the letter J? Think about the months that start with the letter J. We're going to use a set braces, and then tell me what those months would be. January, what else? June and July. Are there any others? So right there, that is considered the roster method of all of the months that start with the letter J. Okay, what about the set of all negative integers equal or greater than or equal to 5? So negative integers, we're thinking about a number line now. -5, -4, -3, -2, -1. Are there any others? -5, -4, -3, -2, -1. That's not an infinite list, so we can actually list out every single one. Okay, the set of all negative integers greater than 5. How is that actually different than the last one? So this is all negative integers greater than 5. Would we include 5? -5? No. So we would have, and this is, you have to get practice with that. -4, -3, -2, -1. I'm much better on the other end than at the beginning. Okay. The set of all the factors of 18. What does this word factor mean? Okay, the way I remember a factor is you think about a factory. What comes out of a factory? Products. Factors are numbers that multiply. 2 times 9 equals 18. So if I want to create a factor rainbow, I could have 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. That's a factor rainbow. If I want to list all the sets of the factors of 18, I would do my set notation. Those are my little braces. 1, 2, 3, 4, 5, nope, 6, 7, 8, 9, and 18. I'm just listing the numbers in between just to make sure that I didn't miss any. So those would be all the factors of 18. That's not infinite. Okay, the set of all integers between 3 and 9. Now, if I'm saying between 3 and 9, again, if I draw a number line, here's 3, 4, 5, 6, 7, 8, and 9. What are the integers that are in between 3 and 9? And would we include 3 and 9? So what would they be? 6, 7, 8. We wouldn't actually use the ellipses right now. We would. Oh yes, these are what we call set notation. So these are braces, and we use them to show that we have a set. Yeah, we're putting them yes, we're practicing them. Okay, the set, that's how we know it's a set. The set of all integers between 3 and 9 inclusive. Well, how is this different, inclusive? Exactly, including 3 and 9. So we would draw our set braces, 3, 4, 5, 6, 7, 8, 9. Okay, we're going to use the roster method to list elements of the set. List the set of natural numbers less than 500. And let's think about natural numbers for a minute. What's the smallest natural number? Smallest number that occurs in nature that you use to count with? 1. So if I want the set of all numbers less than 500, I could start with 1, 2, 3, because these are natural numbers, dot, dot, dot. And then less than 500, where does this list stop? Yeah, and actually let's do 3 so that we can establish a pattern. So 499, 498, and 497. Oops. You'll get good at practicing those, okay. The set of even integers. What could be the set of even integers? Yeah, 2, 4, 6. And actually, if we're saying even integers, I wonder if we should include negatives. What do you think, Brandon? Negatives too? No, integers could be negative as well. So I think actually we would go like this. Negative 4, negative 2, 0, 2, 4, dot, 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 this direction, dot, 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 this direction. Because integers include positive and negatives. The positive multiples of 10. What does that mean, multiples? How would you define multiples of 10? So that would be factors. Dividing it into 10 would be factors. If you say multiples, multiples would imply a multiply. So when you count by 10, you have 10, 20, 30, 40. These are multiples of 10. Are there a limited number of multiples of 10? We would call it infinite, so you could use your dot, 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 your ellipsis, to show that you're going to keep going using that pattern. The set of all integers between 500 and 600 inclusive. The set of all integers in between. So I'm including 500. So I'm starting at 500. What's the next integer after 500? 501 and 502. Now that would be a lot of numbers to list, literally 100. So I'll use my ellipsis to connect and go 598, 599, and 600 since we're including the endpoints.